look at it. And I thought it was a nice one, and I may have taken this from the textbook. Yeah, not bad here. So it says out -4 down 2 is a part of this graph. Go ahead and label and get ready for this. -4 down 2 is right in here. I see it goes 0 up 2, and I will connect those here shortly. And that's closed in. Out 2, up 2. Right here. Looks like that's closed in. And then 4, 0. On the arc, watch carefully so you know before they turn the papers in tonight what I'm looking for here. Guys, if I applied my points correctly, I think they're all correct here. I better do this. Sounds like doing it 0, 2, out 2, up 2, 4, 0, and -4 and -2. Let me connect this the best I can here in the black. And accept this as my parent graph. And when I scoot to the side here, please tell me, does it look something like that on your handout? Something like that, okay. Now, Michael, that's my parent graph. What do they ask me to graph first? And we'll try to graph it in red.
Y equals f of x plus 3.
Y is equal to, hang on just 1 second. Y is equal to f of x plus how much?
3.
Oh my goodness, this was a gift. What does that plus 3 indicate? A vertical shift up 3. Now, you gotta take this parent graph and show me vertically shifted up 3. What would be a good way to do that? Without just jumping in and say, I'll do it quickly. You know, I want to see a nice graph. What might you do with those points I have labeled to show a vertical shift up 3? I gave you 4, I think it's 4 points that are labeled. And of those 4 points, guys, what should I do with those 4 points to get a nice graph because I got shifted up 3? What does that mean for you to do? Add 3? Add 3 to something. Now, which direction am I going? Up. Or down, could be down, but this was up. So is that the Y or the X? I want to move up and down. Is that the Y? So it says here, go to each one of these and add 3 to the Y coordinate. So I'm at -2 for this one. If I add 3 to it, guys, please tell me, am I now at -4 up? Am I on top of the board here? Am I at -4, 1 now? Yes or no? With a vertical shift up 3. They gave me 0, 2. If I add 3 to that Y coordinate, that's going to take me up to 3, 4, 5. If I have no mistake, that's there. I got 2, 2. Add 3 to the Y, that's going to take me out 2, up 5. It's here. My last point they gave me was 4, 0, add 3 to the Y coordinate, which is 0. I'm going to end up at out 4, up 3. And guys, this is right in here. It looks like it's here. Does that look reasonable? Went through and added 3 to the Y coordinates. I did not label them for you, but if I connect, it should resemble the parent. The parent graph. And here. And then here. Let me step to the side. Please tell me, does that red graph resemble the black? Except it's been vertically shifted up. In fact, shifted up 3. That's all I want. I'm leaving the harder ones for you. You start your group work here shortly. But that one's done. Michael, what they ask me to do next? Whoa, 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 whoa. Y is equal to a negative sign out front,
Yes.
and then,
F of 2 minus x.
whoa. Oh boy, I did jump into it.
Minus 6.
Uh-oh. Oh, no, Ramsey, no, are you gonna do this before you release your students in the group work and have them do something? Oh, my goodness. You sure that's, how many problems are on that handout? 4? And this is number 2? I need some big time help here. This, what type of transformations am I gonna be doing on, I'm supposed to go back to that black graph. I'm gonna erase the red word so I can get some space. And then apply these transformations on that black graph and get the blue one. Guys, help me out here, let me use different colors here. When I finally get to the transformation, this might tell me to do what? Reflected through the x-axis. Vocabulary here, reflect through the x-axis. This one's gonna drive me a little nuts. Now it says f of 2 minus x. Michael, I think you mentioned to us, I don't know whether I wrote it down over here somewhere, probably did. Didn't you put something like x minus c, or you told me something about x minus c? And x plus c, something somewhere in here? Was it? X minus c and x plus c? Well, I'm looking at mine right here, it says 2 minus x. Can someone tell me in this clever class? Been bragging on some of you guys already. Can someone tell me what's wrong? What adjustment? How must I modify this to fit what he read to us earlier? Does anyone have an idea of what's that 2 minus x that bothers me? I'm trying to make it fit the category. The rule. Here again. Ooh, get close. You want that x to come first? Hang on. Look at that. You said, wait, Professor, maybe you should turn it around. Have the x come first. Because I think you had the x coming first in your rule there, didn't you? X minus c, x plus c. Is that true? Getting closer. Not quite there. Can't use the rule yet. Now, can someone suggest now what would I do after I turned it around? At least the x is out front where it should be. Now what? And this is the clever part. What else are you going to do now to make it fit?
Reflect across the y.
Do it again.
Reflect across the y.
Oh, I love that. We are going to do that when I get started. Absolutely, we're going to do that. But tell me at this point, what must I do at this point? We are going to do a reflection to the y-axis. But what am I going to do right here? This still bothers me. It's not in the form I need. We place the x out front. That was needed. What else do you think I need to do before I jump in and start identifying the other transformations? They're going to be shocked. And it's got to be done. Who has an idea? Negative x plus 2 must be modified.
Factor out -1.
Factor out the negative. And make it look like this. Oh, aren't we going to have fun? Aren't we going to have fun? And by the way, guys, this right here, if you go ahead and use the distribute product, distribute that negative sign, this will take you right back to this. I've just rewritten. Now, why did I rewrite it? Michael says the x minus 2 professor tells you eventually you got to do a horizontal shift to the right by 2. Oh, and I have now a negative sign inside there. I think you discussed something about negative sign being placed inside somewhere. Maybe I didn't jot it down for us. Guys, what happens if you have a negative sign inside? It's not out front, it's a reflection through the what? Y-axis. So I've got 2 transformations happening right there. There's reflection through the y-axis. Let me do that in green. In fact, I may have a student come up here and help me on this. So we put this says reflect through the y-axis. I'll do that in green when I finally get to it. The x subtract 2, I'm doing in red. Says, don't stop there, Professor. That says there will be a horizontal shift. And Michael described it as to the right. 2 spaces. Wow. We agree so far? Now, one more transformation. That's why I asked him, especially, he said, no, Professor, there's a subtract 6 on the end. Does anyone have an idea of what on earth might, look at this carefully here, guys, okay, that negative 6 on the end indicates for me to do also? Negative 6 on the end.
Shift down 6.
Vertical shift down 6. Are you kidding? I was going to use black, but I have my graph in black. Okay, guys, let's see. Okay, I'm running out of colors here. Okay, this right here. A vertical shift down 6. If I keep my wits about me and go back to my parent graph and I'll start crying and do this and get a nice graph, a transformation, a transformation, a transformation, and finally the final graph. Okay, guys, on, let me erase this. This one's an example. Earlier. Okay. Now, I don't know, I'm gonna throw it out there before you even work with my TAs. Anyone come up and show us the effect of the transformation resulting from this, which we described as, please reflect it through the x-axis. Take that strange parent graph and reflect it through the x-axis. Can anyone tell me, or can someone come up and be neat and show me what you think this parent graph would look like if I flip it over the x-axis? And label the points for me. Thank you. Guys, look what she's done for us. Please look at the orange. It's orange here. Does her orange graph look like maybe the black just reflected across the x-axis? Definitely this piece here, the horizontal piece, she says Professor's down here now. Is that true? So you can look at all the pieces, would we agree with that? If so, I'll accept that. I think it's done correctly. True? Thank you, thank you, thank you. Now, here comes trouble. The next transformation says do this. To her graph. It's a sequence. So now take her graph and now do that, and we identify that green part coming up as a reflection through the what? Y-axis. Is it true? Now, does anyone think they could come up and show me what maybe that orange graph reflected through the y-axis may look like? This is madness. I need a volunteer. Her graph reflected through the y-axis. In other words, this piece right here, that's on the right of the y-axis, it's got to go there. And this piece that's on the left of her graph, on the left of the y-axis, it's gotta go over here. There's one thing they know what that might look like when you flip them over the y-axis, reflection across the y-axis, and come up and do it in green. She did a beautiful job on the orange. Any volunteers for the green? It's getting tougher. And I'm trying to get you to help me because I don't want to do it. It's really, really tedious. Any volunteers for the green? Come on. Absolutely. Show it the best you can. Just take your time on these things when you're creating. Let's get that clock is correct. Please do it, that clock is correct. Is it correct?
No.
Did we have a time change over the weekend?
Yes.
Did the clock change?
No.
How do I change? Oh, good. Okay, by the time class puts in 7:25, by this clock. This clock says it's not even 6:30 yet. Is it true? Oh, I like this clock. Okay, now, let's take a look and see what's done here. The green, guys, I would think, I'm looking at, look at this, that little orange piece, I love it. This little orange piece, taken across the y-axis is here. Does that make sense? This is here now. It's directly across the y-axis. It's called reflection. This piece right here is now here. Is that true? This piece right here is now reflected across the y-axis. Is here. I'm looking at others on the orange. Are we finished? Anna, Park, is that the complete graph on the green? I think it is it guys? After you reflect the orange across the y-axis? Is it? Or is there a piece missing? Is there a piece missing? Michael, come up where? I thought I was finished. When I looked at the work, I thought it was finished. You see a piece missing? If so, we got to put it in. And then I'll let you guys try one before that time. New times will catch up with me. Guys, does anyone see, is there a piece missing? Because I see right now, definitely this, I love this, is now here. This is now here. So those pieces have been reflected across the y-axis. What else was there to reflect? This piece here, what should that be, guys? Or is it done? You think it's done? If it's done, we'll just say, yeah, Professor, move on. It's done. You think it's done, guys? Uh-oh, Michael says, hold on, you may want to just modify it a little bit. We'll see. I put it in green. Oh, you got it in green, okay, okay.
Doing a blip.
Do it green, green, do it green. think we agree. Guys, a little adjustment, on the green, now hang on now, I see lots of green here. Yours, is this the graph?
Here, there.
Oh, here, and here. Hang on. Yes, so you say, erase this. Erase the part that you don't want. Guys, he says the green looks like that. Do we get an agreement or not? Step aside there, let's see it. He says the green looks like that. I haven't done it myself yet. I'm sitting here saying, I don't know, Professor. I don't know.
It's not finished.
Oh, no, it's not finished. You got more green.
Can I do it in a different color? Cause it needs to be vertically shifted.
Okay, hang on just 1 second though. Okay, guys. Mike, I don't put you on the spot there. Have a seat, guy. I don't put you on the spot.
Thank you.
I think students realize what's happening now. We gotta be careful on these. You gotta keep in mind, when we finally decide what the green does look like, and who knows, the original may look like it looked pretty good to me, the original did. But we modified it a little bit. Then you gotta do this to it. You gotta do the red. And if that's not enough, then you gotta do what to the red? The black. We'll be here all night. I'm glad that clock is set like it is. I need the time. You see the confusion here? Who would not be confused with all those different transformations to do? And finally, that last transformation is the graph we're seeking. I have not done it with you guys. I want to get some input from you guys. Yes.
On a quiz or an exam, if we wanted to do them separately, could we, or?
Oh, I got you. You're saying, Professor, with all that placed on one grid, it bothers me. So could I, beautiful, I love that. She said, Professor, can I take your parent graph and maybe do one transformation on it, and then come over here and do the second one on a separate grid? Because all that placed on one grid is gonna drive you crazy. And I may not have all those different colors on quiz day. Could I do each one on a separate grid? And then finally down here, that's the last graph. See what she's asking? Which might be wise. Do the red on one separate grid, do the blue on one separate grid, beautiful. And do it like that on separate grids. Yes, absolutely you do that. You see how confusing this thing can be right now. And I'm going to show you something while we're out of time here that might lead us into something a little bit easier. I love that where you can do it on separate grids. Absolutely, you can do that. Guys, with all that said, Anna, Park, do we have about 15 minutes? We got a good way to do this. This is a little extra credit points. Not many points, maybe a couple points. I want something turned in. Okay, Anna? My dear, do you want to work on the board over here with your group? And then Bart, can you maneuver over here and